Geometry Unit 6, Lesson 7, Arc Length, Sector Area, and Radian Measure. So in this lesson we want to look at formulas for arc length and sector area, and then we also want to look at another way of measuring angles instead of degrees. They're called radians, and we want to be able to switch between those two. So we already know what an arc is. It's when we have part of the outside of a circle. Now we've measured that before in degrees, but it also has a length based on what the radius is. For example, this is another circle. It's going to have this arc, and this one that I've marked here will have the same degree measure, but they have different lengths because the radius is different. So we now want to look at the arc length of that as well. How long is it in some sort of measure of linear units like inches, centimeters, and so on. Then the sector of the circle is the part of the circle that's cut off, and we want to know its area. That will also depend on the radius. So this part does not have the same areas as this, even though the arcs have the same degree measure. What we're really going to do is we're going to see which fraction of the circle that arc or that sector takes up, and then we're going to take that fraction of either the arc length of the whole circle, which is the circumference, 2 pi r, or the area, which is pi r squared. So this really m over 360 is the fraction of the circle that the sector takes up. This is the fraction of the circle for the sector. So if the sector is a half of the circle, you multiply by 1/2. If the sector is a third of the circle, you multiply by 1/3. If it was a quarter, you'd multiply by a quarter, and so on. You can do that by simply taking how many the degree measure for that sector and then dividing by 360. That tells you what fraction of the circle that sector represents. And then you're going to take that fraction of either the circumference or the area. So on a clock face, the minute hand is 10 inches long. How far does the tip of the minute hand travel as the time goes from 12 to 15? So we know that 15 minutes is a quarter of an hour, so that means it's only going to go a quarter of the way around the circle, so we need a quarter of the circumference. Or if you like, it goes 90 degrees to go from 12 to 12:15, it goes 90 degrees. So if we want the arc length, it's 90 compared to 360 times the whole circumference, which is now 2 pi times the radius. The radius we're given is 10, that's the length of the minute hand. Or we could just say directly that we know that that is a fourth of the circle, and then that's times the circumference, which is 20 pi. That now gives us 5 pi. If we use the pi button, that will tell us at about 15.7 meters. All right, here we have a sector which is marked, which is 120 degrees. If we want the area of this sector, again, we need to take the fraction of the circle, so it's 120 compared with 360 times the area, which is now pi times the radius squared. Or we could directly say, well, we know 120 is a third of that, so we would take a 30 of that. This is 225 pi. And if you get that, 225 is not, it is divisible by 5, because 4 plus 5 is 9. So if you take 225 and divide by 3, this is 75 pi exactly, or if you use the pi button, that's about 235.6. This was in millimeters, so that's millimeters squared. We could also find the arc length, like if we wanted to find the length of the arc AB, that S would be now a third of 2 pi times 15, which is now 10 pi, or approximately 31.4 millimeters now for that arc length. They only asked us for the area. I'm just saying that's, again, what you would do here for the arc length if you wanted to know how long that was. Now the last thing we want to look at is another way of measuring the arc itself. Instead of in degrees, we can use something called radians. And if you look at the formula for the arc length, you're taking that fraction of the circumference. But now we know that for fixed m, this part, so if we have a fixed degree, just like we were talking about different circles, it depends on the radius, there's a constant there. If we simply multiply that, it is pi over 180 times that fixed degree. And therefore, we could write that the arc length is just that constant. Of course, that constant depends on the degree we're talking about, and find that length from that. So the radian measure is from that. We're going to take pi times 180 times the degree measure, and that will tell us how many radians it is. Now, I believe that's an m. There are 2 pi radians in the entire circle, so 360 is 2 pi. So if I want 180 and I want to convert it, I would take pi over 180 times that 180. That would cancel, and this is just pi radians, so 180 degrees is pi radians. 60 I would take and multiply by that 180. Generally, you want to look if this gives you a nice fraction, you're going to use that, so that's a third. So that would be pi over 3 radians. If it doesn't give you a nice fraction, then you actually go ahead and multiply by that pi. But this again is another way of measuring how many degrees the angle is. And if you're using it for like tangent or something, as I said, you can do it in either one. This year we've done just degrees. Some years you're going to end up using radians as well, and you have to switch them. For calculating degrees and radians, you don't need to worry about that. The only time you need to worry about that is if you're using any of those trigonometric functions on your calculator.